Let's take a look at this example. From where we're supposed to start? Always look for the component which has two pieces of information first. Okay, so we have R3 which has two pieces. Okay, so we are going to start from this point. But before we are going to start, let's check what we're supposed to find. So I have to find voltage source. Okay, I'm supposed to find value of R1, which is equal to R2. So we can say also we have to find R2. We have to find P2. Okay, and this is basically it. Now I have two pieces information at resistor R3. I got the resistance and I got the power. From these two pieces I can find the voltage. If I'm going to find voltage across this resistor, I'm going to find voltage across rest of the resistors plus voltage source, because in parallel circuit all voltages are the same. Let me remind you one more time. Voltage source is equal to VR1, this is also equal to VR2, this is also equal to VR3, because this is the parallel circuit. So let's take a look over here. I have P3 is equal VR3 to the second power over resistance R3. Okay, I have given power, I have given resistance, I can find the voltage. So in order to solve this voltage, I have to eliminate the fraction, because voltage is the part of the fraction. So what I'm going to do, I'm going to multiply this formula, okay, by the denominator of my fraction. So what I'm going to have, P3 times R3 is equal VR3 to the second power over R3 times R3. R and R will cancel out. Okay, so I'm going to write that VR3 to the second power is equal P3 times R3. But I'm not looking for voltage square, I'm looking just for voltage. So what I'm going to do in order to find V, I'm going to square root both sides of my equation. Okay, and I'm going to obtain VR3 is equal square root of P3 times R3. Okay, so this is equal square root, open parenthesis, P3, we have torre milliwatts, times R3, which is equal torre kilo ohms. This is equal, and I have VR3 is equal, I'm going to use the calculator, so I have square root, open parenthesis, we have torre exponent -3 times torre exponent 3, close parenthesis, this is equal torre volts. Okay, so VR3 is equal torre volts. If VR3 is equal torre volts, it means that voltage source is equal torre volts, VR1 is equal torre volts, VR2 is equal torre volts, and of course VR3 is equal torre volts. But please notice how this voltage source is connected to the circuit. Okay, the positive terminal is connected to the ground and negative terminal is connected to the top of the circuit. So if you are going to connect the voltmeter between, let's say, let me call this point A, between point A and ground, okay, so you are going to measure negative voltage. That's why I'm going to say that this voltage is equal negative torre volts. Okay, we found the voltage. If we have the voltage, we can find the current which goes over here, right? Current in this circuit, we are going to use Ohm's law to find it. Okay, so we have I3 is equal VR3 over R3, which is equal VR3 minus 30 volts divided by R3, which is equal 30 kilo ohms. Okay, this is equal negative. This is very simple thing to calculate, but let's practice the calculator. So I have 30 negative divided by 30 exponent 3. Okay, so this is negative 1 milliamp. So this is negative 1 milliamp. Okay, so this is the current which will flow through the resistor R3. Next, I'm going to find the currents which go through these two resistors. Okay, please keep in mind that I1 plus I2 plus I3 is equal I total. Okay, this is the KCL, Kirchhoff current law. Okay, the sum of these currents is equal I total. So I total is equal 2 milliamps. Okay, this is my I total, 2 milliamps. I total. So let's plug in these values into this formula. Let me write this down over here. We have I1 plus I2 plus I3, which is equal negative 1 milliamp. Okay, and we have also I total. I total is equal negative 2 milliamps. Okay, so now we have I1 plus I2 is equal, I'm going to move this negative 1 milliamp to the right side. So I have negative 2 milliamps. I have to change the sign to the positive, so I have plus 1 milliamp. This is equal negative 1 milliamp. Now, please notice that these two resistors are the same. R1 is equal to R2, so it means that the currents in these two resistors are going to be the same. So if I have 2 milliamps as a total current going through the resistor R1, R2 and R3, okay, so this current is going to split. These currents are going to go like that. 1 milliamp will go through resistor R3, and remaining 1 milliamp is going to be divided into these two resistors equally. Why? Because the resistances of these two resistors are the same. So because let me just write this down. Because R1 is equal to R2, okay, so it means that I1 is equal to I2. Okay, so I'm going to write down that I1 plus I2 is equal to I1, or we can say this is equal to 2I2. This is the same thing because these values of the currents are the same. And I can rewrite this equation as 2 times I1 is equal negative 1 milliamp. Okay, Okay, instead of I1 plus I2, I simply write 2 times I1 or 2 times I2. Doesn't matter which one you are going to use because these two currents are identical. And in order to find I1, I have to divide both sides of my equation by 2. So 2 and 2 will cancel out, so I have I1 is equal negative 1 milliamp divided by 2 is equal negative 500 microamps. But let's use the calculator just to make sure that everyone will understand what's going on. So I have 1 negative exponent 3 negative, this is 1 milli, divided by 2 is equal negative 500 microamps. So this is my I1, and we said that I1 is equal to I2, that's why I2 is equal negative 500 microamps. Okay, so this is my I2. We found the currents which go through resistor R1 and R2. Is supposed to find P2. Okay, P2 is equal I2 times VR2, where P2 is equal, I2 is equal negative 500 microamps times VR2, which is equal negative 30 volts. So I have 500 negative exponent 6 negative times negative 30. This is equal 15 milliwatts. This is equal 15 milliwatts. This is my P2. We have to find R2 as well. So to find R2, I'm going to use Ohm's law. R2 is equal VR2 over I2. VR2 is equal negative 30 volts divided by I2, which is equal negative 500 microamps. Okay, this is equal. Negative and negative will cancel out, and I have 30 divided by 500 exponent 6 negative. This is equal 60 kiloohms. 60 kiloohms. Okay, so we found voltage source, we found R1, we found R2, okay, we found P2. Okay, someone is going to say, hey, you didn't find R1, but keep in mind that R1 is equal to R2. So in this case, 60 kiloohms is also equal to R1. So we found, one more time, voltage source, R1, R2, and P2. So we can say that the problem is solved.